We will solve the following exercise. Exercise is number 2.13. Two snowcats tow an emergency shelter to a new location near McMurdo Station, I think, Antarctica. The top view is shown. The cables are horizontal. The total force Fa plus Fb exerted on the shelter is in the direction parallel to the line L, and its magnitude is 400 pounds. Graphically determine the magnitudes of Fa and Fb. Alright, so this is the information that I need, and this one. The total force exerted is equal to 400 pounds and is parallel to the line L. Alright, so there is one important thing that is happening here, and I wanna teach what's happening by using, for example, these three vectors. For when I'm creating a summatory of vectors, graphically speaking, then what I have to do, or what I have to comply, is one requirement. I'm gonna create one resultant shape with these three vectors. Let's imagine that there is, I don't know, 4. And as you can see, the requirement that I have to meet is that the tail of the vector must be touching the head of one of the other vectors, alright? So when I move it, I had to comply with this requirement. As you can see, tail with head, and tail with head. The order does not matter. The answer will be the same, right? For example, if I do this, the answer will be exactly the same, right? I just have to meet that requirement that I just said. Then the result will be the magnitude between these 2 points, and there is going to be a vector generated the other way around. The tail must be touching the tail of one of the corner vectors, and the head with the other. Alright, so right here I have the magnitude, and that is going to be the answer. Alright, so when they are telling me that the summatory between these two vectors is equal to 400 pounds, and that 400 pounds are generated parallel to the line L, then what I'm going to have is this. Right here I have FB. Then right here I have FA. And as you can see, right here I'm going to create a resultant vector. As I just said, the vector must be touching the head of FB and the tail of FA. So right here I have FB, FA, and right here I have the 400 pounds. Alright, I do not like this sketch, because the 400 must be something close to a vertical line. So bear with me while I create another one. So right here I have FB, right here I have FA, right here I have the 400. At this point I do not care about the unit system, the pounds. I just care about the magnitudes, right? So the 400. Okay, once I have this, I'm gonna start creating or writing down the angles. Right here I can see that the angle generated between L, which is the same angle with respect of the resultant vector, is going to be 30 degrees. So between FB and a vertical line I have 30 degrees, and with respect of a vertical line and FA I have 50 degrees. They're asking me for the magnitudes of FA is equal to what, and FB is equal to what. Okay, what I'm going to do is to find this angle. The first thing, I'm going to start playing with angles, trigonometrical identities for me to find these two values. So this angle, I'm going to call it alpha, and there is one statement that you should remember, and is that the symmetry between the angles within a triangle must be equal to 180 degrees, right? So that means that 50 plus 30 plus alpha equals 180. Then that means that alpha is equal to 180 minus 50 plus 30 is equal to 80. That means that alpha is equal to 100 degrees. Am I right? 50, 60, 70, 80. That's right. So I have right here the angle alpha, which is equal to 100 degrees. And then once I have all the angles within the triangle and one magnitude, it is easier for me to use the sines law. Why is that? Because using the sines law, what I'm going to do is to create an equivalence between the angles and the magnitude. So bear with me while I create this, and then I explain what I did. Okay, this is equal to FB divided by the sine of 50. This is equal to FA divided by the sine of 30. Alright, as I just said, I'm creating a correlation, an equivalence between the magnitudes and the angles. Alright, so for when I want to create a correlation, I have to take into account the magnitude and the opposite angle, in this case 30. Okay, so for FA, the correlation would be the sine of 30. So right here I have FA divided by the sine of 30. The same thing happens here with FB. So FB is right here and the opposite angle is 50, so sine of 50. And right here I have the 400 and the angle 100. Alright, so I'm gonna start by taking, for example, this part of the equation for me to find FB. So FB, the magnitude of FB is going to be equal to 400 divided by the sine of 100, and this is multiplied by the sine of 50. And the magnitude of FA is going to be equal to the same thing, but multiplied by the sine of 30 instead. Right? So I'm gonna put this on the calculator. So 400 divided by the sine of 100. I have to make sure that I'm using degrees. Right here you can see that. Multiplied by the sine of 50 in this case. Right, this is equal to 311.1447. I always use 4 significant digits after the comma or the point. In this case, now I do care about the unit system, so we're talking about pounds from the beginning, so it is equal to pounds. And then I'm going to change that 50 for a 30 for me to find the magnitude of FA. Is equal to 203.0853 pounds. There is one way in which I can check that these two answers are correct, and this is by using a software. In this case I'm going to use CATIA V5, and all we have to do is to create this shape. We're going to define it using this value and these angles, these two angles actually. And then we're going to measure these two lengths and that would be, if we did the exercise correctly, that would be equal to these two results, right? So remember that you have within the channel some tutorials about this tool for you to learn how to use it, about CATIA V5. So as I just said, I'm going to create the shape. So bear with me while I do it. Here I have this angle, and right here I have this angle. Right, as you can see, it is showing me in green the lines because everything is defined. That means that I cannot move anything. If I, for example, do not have this angle, then I would be able to move this, as you can see. So like this. Then I'm going to change the values for the ones that we need. This is equal to 50. This is equal to 30. And this is equal to 400. Okay, as you can see, the shape changed. And all I have to do is to measure these two lines. Reference. Reference. Alright, as you can see, FB is equal to 311.144.7, but the system, what the software is doing, it is approximating the values. Why is that? Because right here I have a 7. So if I want to use just three significant digits after the comma or the point, then I would have to change this value for a 5. Remember that if right here I have a value between 1 to 4, then I would have to stay with this value, with this 4. But if I have a value between 5 and 9, then I would have to change this value for the one that follows, in this case 5. So that is the case, and that is why the software is showing a 5 right there. The same things happens right here. Right here I have a 3, so it is between the gap of 1 till 4, so that means that I must stay with this value, right? And that's all, guys. This is how you can solve this exercise and check it.